Hello, everybody. Got some fun stuff today. All right. Get my windows organized. Nice. Oh, and actually I wanted this open. There's the commits. There we go. Okay. Yeah. So I'm going to go through how I fixed things last night. I actually fell asleep and then woke up. I was like, I know the answer. And I got up and coded till like 5 a.m. So all the problems I was having with the bounding is gone. Or the map gen. And I have new ideas too. Let me just do make run. So this is the map, but it's inverted, and I'll explain that in a bit. This is actually going to be a room, and these would normally be walls. So you can see room, 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 and so on. So I'll talk about that in a minute. That's actually a kind of an inversion of what I was doing. Code is still not crazy clean, but I have some new ideas to optimize it a bit. And we'll do that today, clean it all up, refactor it, and then do the next part, which is finding the paths to make doors and stuff. And that's what this inverted matrix is. So the idea is, if I have rooms, I can randomly put a door, say like here, invert the map so that what is normally considered wall is considered empty space, and the room is considered wall. Then run the Dijkstra algorithm, and what it'll do is it'll give you paths from one room to another automatically. Now this isn't quite correct because I just put zeros on the doors at like the same spot, but even that you can kind of see 0, 0, 1, 2, 3, 4, 4, 4, 4, 4, 3, 3, 0. There you go, got a path. So I think this will make kind of like more fun paths to each of the rooms. But what I most likely have to do is add a door randomly to each room, kind of pair them up, maybe randomly, right? Add a door, and then run the Dijkstra algorithm, with 0 on the target door, and then just follow the path to the target door. And do that for each room, and then you basically have kind of winding paths going through the dungeon from room to room. Then flip it back and you've got yourself the whole thing done. So that's the general idea. That's the next thing we're going to kind of work on, because you need paths between the rooms for it to work. Alright, I think the music needs to be... Oh. Yeah. There we go. That's better. Alright, let me see if there's people here yet. Alright. So we'll get going at 4. I'm just kind of doing a bit of cleanup. Alright, let me start a timer and let me take a short break. I'll be back in probably 4 or 5. Let me just get some tea, folks, and I'll be right back. All right, I'm back. Okay. So we're going to clean this code up. It's working. But I can make it way better. Some nice optimizations I can do. First, let's talk about what I had to fix from yesterday. All right, so the problem yesterday was... I was, like, if I were to draw this, so I have a room, we're doing binary space partitioning, right? So let's say I pick this, right? Now what I want to do is I want to then pick another partition here and one here. So I have the split. So let's say this is the split. So let's say it's at coordinate 10 or something like that. What I was doing was, I was using, to find this split, I was using X as a basis and the length or the width, height or width of the space to determine where to split it. Okay? Which works when you only have 2 rooms. But then if I split it again, so let's say I go to split this one more time. Okay? Well, if I use X, X is going to be like here, right? and there. So the width, right? I was using X or Y, but the actual only thing I need to do to find out where to do the split is I just need this dimension. I just need width. That's it. I don't need X or anything. So if I want to split this space, I don't need to have like the coordinate for the box origin. I just need the width. I think you just got lucky. Yeah, they run it at 5 minutes in, which is weird because that's basically a pre-roll ad. But anyway, I think I can adjust it. I might go and adjust it to about 10 or 15. Anyway, so the error I was making yesterday is to determine the width for the split, to determine this width here, the green line, I was using the X coordinates or the Y coordinates, right? So I was doing like the width plus the X coordinates, and that was making the boxes effectively do this, and then do this, and then do this. All I need is the width. That's it. From there to there. That's all. So that was the first fix. Just basically, just use the width, cut about 25% off the sides to give it a little bit of space, pick a random spot in the center, and done. Right, so that was the first fix I made. And if we go look at this, and then just a few more things like setting the bounding box a bit better. If we go look at this, let me see. Yeah, so I rewrote the make split. I also don't need an if statement. Once I figured that out, if all I'm using is the height or the width, I don't have to know the X, right? So all I need to do is, if it's a horizontal split, then just grab a dimension, that's it, and then everything is based on that one single dimension. So divided by 4 to get like a 25%. That's your minimum. Your maximum is that minus the minimum. So that gets you kind of like, if you have two sides, gets you like sort of a bounding box about like that, and then you'll pick anywhere inside there. And then uniform distribution is just min to max. That's it. Works every single time. So that was giving me a better split that wouldn't go off the map. Before I'm using X, I'm adding it to that dimension. It was slowly creeping out. Okay. So that was the first thing I had to fix. And then this too. So then that turned into getting rid of the X or the Y coordinate almost everywhere because you don't need it. You just need to have a room with an origin point and a width, and then the rooms can all be built. I also got rid of keeping track of the root and the current. All I really need is the current, so I don't need the root. Got rid of that. And then if you go and look here, I got rid of these too. So these turn into 0 and the height, so it's going to be the full width because now I'm cutting in by 25%. And that was the big fix. So then after that, it was like just a bunch of little refinements to kind of get a better layout. So for example, I also had to sort of like work on the way you construct the map, because remember in the FTX UI, it's using kind of subpixels, so you can draw like more complex lines. So if I have a 50 by 60, then I just do that. And then just a bit more tweaking. Really, everything was just all about kind of tweaking and refining it after that. All right, and I'll show you the results after. Oh yeah, and then the other thing was, in the description of the algorithm, they're constantly picking a random direction. Right? Oh no, this was just more tweaking, but they're constantly picking a random direction, right? So what they were doing is they were going like, okay, I got a box. And then they're going, okay, pick a random direction. Roll your dice horizontal. Right? So then they're going to make a line like this. And then you go, roll the dice horizontal again. So you would end up with these rooms that were like this. Just by random chance, you could end up with these kind of almost like a sandwich setup. Okay? But if you switch it to always pick the widest dimension to cut, that lets you use, like, say, a room like this. So this is the widest dimension. You just pick a random point in there. Now, this, they're equal, so you can just pick a random point inside there. Now, this is the widest dimension again, so pick a random point in there. And then this would be the widest dimension. Then this here, that's the widest dimension, so pick that. So all you really have to do is just pick the widest dimension, and you get the best layout. You get like basically a really nice looking layout that looks random, but everything is kind of like in a decent size. It's not super elongated or anything. And so after that, I got something like this. It'll look a little weird because there's another idea that we're going to work on today. And so it's a bit tough to read. Let me zoom in. So you can see, because this is inverted. So remember before, dollar signs were representing wall. So normally this is wall, right? So this is a room, and this is a room, and I'll run it again without this small fix ahead. This is a little room, this is a little room, this is a little room, this is another room. So you see, you get kind of like better sizes. Okay, now what this is I take the walls, and basically I take the map and I invert it. So now it's rooms are walls and walls are room. Then you run the Dijkstra map, right? Now what does Dijkstra do? It calculates paths. So all I really need to do, if I just set a door, so basically there's a door there, anywhere you see a 0 is a door. Run the Dijkstra map, and then I just need something that goes, like let's say I want it from here to there, I go 0, 1, 2, 3, 3, 4, 5, 6, 0, 0. Okay, I got a path like that. So the way the other description of the algorithm was you pick pairs. So you would pick these two, and then you would connect them, and then you pick those two and connect them, which makes it kind of boring. But if I just pick random rooms and then pair them up and say, okay, I'm going to go from this one to that one, Dijkstra map it, run a path that just walks like, you know, basically it's walking to the door, and then I'm thinking you're going to get way better paths. So you can get paths that kind of more go like this, right? So this is sort of like just like playing with that idea. So yeah, I got up at like 3 a.m. last night. I was like, I got the solution, and I fixed it in like 2 seconds. All right, now let me undo that so you can kind of see how it actually looks, minus any of the things. And then I've got a cleanup that we can do based on some ideas. Okay, I think I did a commit with this change. It was meant to be temporary, so I gotta here, yeah, okay. So walls need to be 1 and input needs to be 1. Okay. And I think that's not gonna do it. There's one more change I need to make. I believe it's in make room. Yeah, I think I have to invert these two. Yeah, so see how everything is wall. So then this needs to be 1. And then that's a door. Let's just comment this out. We'll say there. Okay, and then this needs to be 0, I believe. Okay. Okay, and there we go. So now we have, and keep in mind the actual canvas is a bit bigger than what we see. So I think if I just, yeah, there we go. Yeah, okay, perfect. So there you go. So we got a bunch of random rooms. Now I'm just placing the dude in like a random spot. So sometimes he ends up in the same spot. So sometimes they end up in a wall. All right, so we got kind of nice random layouts. Right, you can see it's like not too bad. Nothing's too long, nothing's too wide. Rooms are like that. And then we just got to basically now, like I said, place a door. I think the next algorithm after I clean this up is pick 2 rooms, place a door on 1. That's where you're going to take the door or place a door on the from. You set this to 0. Run the Dijkstra algorithm, and then you just walk the numbers down until you get to that door, and that's the path. So invert the map, do room, and you can almost do it at random. random with not reselection, and then done. You got your paths. Okay, so. And actually, I'm going to nuke this code. And I might set this as an option in a second, but let's go. Okay, so we got that. Now, cleanup. So here's the thing. I also had to sort of sort out how these leaf nodes get placed on. And I realize you don't need to keep a whole tree. So the ideal thing would be if we have this draw map code, we don't want to do any recursion. What we want is we just want a list of all the rooms. That's it. So when we're done, we just want one list of rooms. And since they've already got their coordinates, they've already got their locations, there's no reason to keep the tree, right? If you think about it, the tree, if I start off with a full space, right? Okay, then I binary space cut it here. Then I cut it here. Then I cut it here. And then I put a room in here. I don't care about this or any of the other parent spaces. I only care about the room. So I don't need to keep these around. Once I know where the room is at, I can get rid of all of its parents, right? Because I don't need to have root space to subspace to subspace to subspace, and there's my room. I don't ever need this. So all we need to do in the algorithm that makes the rooms is when we get to a leaf node, we don't even need to push it on. We just have the functions go down. When they get to their, hey, I can't go any further, just add it to a list. Done. And then when we draw the map, we just go through the list. When we want to do doors, we go through the list. When we want to do paths, we just go through the list. We don't even care about the organization, because the tree organization doesn't really matter. Eventually, we don't want to have any kind of tree organization to it. We want paths to be kind of random and all over the place. So let me confirm that build works. And then first thing we're going to do is get rid of the partition structure, turn it into a room, pull this up into the class to kind of clean it all up. And then I'm going to make that change to where all it does is construct a list of rooms. And then from that, we're going to just go through the list of rooms to draw them, the list of rooms to do the paths, and so on. That's the goal for today. Okay, so first thing I want to do, let's get map.hpp. That's not going to work. All right, so I want to get rid of this. And I'll do the conversion, but basically by making that change, this will go away. That's the goal. Classic mistake of not enough semicolons. Alright, cool. Still working. Alright, now we want to have draw map in here so we can get rid of this because that was stupid. And eventually this will go away and then it'll just know it has a list of rooms. Alright, so that should be pulled up. All right. Okay, cool. All right, so we have root rooms. We have that. Okay. Yeah, let's also do it on this. And this is pretty disorganized. Let me do this. Right, and then Okay, we need to keep this random generator around somewhere. Alright, in theory that should keep going, but it means we got to do this, and I'll refactor that in a second. So it's just something that's kept internally. Yeah, these should be done in maybe a constructor or just as a global. Yeah, something like that. Okay, refactor that. Alright, cool. Still working. Awesome. You got generate, draw map, partition map. Alright, make split's just more or less a utility function, so it shouldn't be in the class. Make paths. Okay, cool. So let me commit that. Okay. Now what we got to do, I'm going to also pull this out. Might as well. Okay, so once we do this, then we're going to do the optimization where I go through and basically when we hit a leaf node, we put it in a list. We'll kind of do that, but also keep the current search tree version going first. Yes, sir. Oh. Okay, cool. Make sure it still runs. All right. So now we want to build a list. We're going to do a vector of rooms. Just that. Something dead simple. Our goal is to be, when we're done with the partitioning, we have a list of rooms that are in the spot instead of a tree. Then we just toss the tree out. Okay, so the first stab at it is here. Yeah, we just push it on there. So we go, oh, let's follow the standard everybody uses. Go there and go there. So in theory, that should give us the exact same thing that we've got with the leaf nodes, but they're just on a list. And then we'll delete this line and rewrite draw map to go through that list. If that works, then we can clean this up to kind of make it a little more efficient. confirm it works. Okay, we got that much. Now we need to make draw map. Just loop through that. So for auto room in M rooms, it's just that. Alright, so if this works, then no point being fancy. Yeah. Let's use cur so I don't have to change too much code. Okay, run it. Aha, okay. Let's run it one more time. It might be an unrelated bug. I think we're adding too many. Yeah, because when we traverse it, it's a bit easier. Oh yeah, we're pushing like all kinds of rooms on. We shouldn't do that. No, this doesn't go here. But this is the idea. We just push it onto a list once we hit it. Yeah, so this is where it gets hairy in my brain because I think these are going to be too small. Okay. Yeah, there we go. Yes. Okay, so I think all we really need to do is just make this bigger. But maybe I gotta delete this code and just rethink it entirely. Oh, and also I'm pushing left on twice. No, I don't think this is the solution. But it's closer. Yeah. Yeah, okay, so we're pushing the wrong rooms on. Also, that means these rooms are going negative. They should not. I actually don't think I need this. We can get rid of that. And then... I mean, honestly, actually, let's get rid of this. And get rid of that. Yeah, so we'll travel down. We should just need to push the current on. No. Yeah, so we need a better terminating condition. That's really what we gotta do. Okay. Are we gonna have an add? Nope, 25 minutes, all right. Yeah, the leaf condition is basically wrong. I think really what we want to do is right here. Okay, so let's traverse the map. Let's get rid of this. Okay, so we're traversing the map still. We just need to know when we hit a leaf node. I think, let me do this real quick. Yeah, let me do that. That's not going to run, but then what we do is, I'm pretty sure we just look for like a range in the size of the rooms. Yeah. Oh, I got an idea. We could just return. Yeah, so we call left, we call right. Yeah, that's what we do. Let me just see if I can detect it. Let's say it's got to be greater than 4 and less than 6 or 10. Right? Yeah. And height is greater than 4 and height is less than 10. So that's our sweet spot. Then we can do M rooms, push back. And then we're done. And return. Now else, if... Then we should do a condition before then. If the current width is less than or equal to 4, or the current height is less than or equal to 4, then just return. And we should log that. So let me grab one of these other log messages. Alright, so let me make sure. If it's greater than 4 and less than 10, then what we want to do is just abort and add it to the list. We found a room. But if it's less than 4, then we want to abort entirely. Less than or equal to 4, we get out of there, if either dimension is. Okay, let's see how that works. I think that's close. Oh, I need a... I don't need split. All right. Oh, yeah. Okay, so let's see what the log does. I should just run make test, but let's see what we get. Oh shit, okay, that worked. Okay, I guess right. But let's just double check. Okay, let's take a look at a little section. Yep, so X, Y, and it's between 8 and 10, this and this. Make a split. And we can also kind of randomize those, right? So we can sort of stop, you know, give it a bit of a wiggle room in there. Yeah, so see, add room. 6, 9, 8, 7. Okay. It seems a bit spread out compared to the previous. Yeah, but it's working. Yeah, it's not too bad. I think it's just more or less random chance. No, I think it's just random. Yeah, that's pretty good. They do always seem to be kind of like tall, but I think that's just refining the parameters more or less. Yeah, okay. And we can shoot for like, we can probably make this a configurable parameter, like the minimum and maximum room size. But let's say we do like 15. And 15. Yeah, that's kind of cool. Now the other thing is we can also tweak where we place the rooms, like how we make the rooms. This is more, I'm thinking of this as more as like the space where the room can go. And then I might start doing like a regular room here. And then it connects to that irregular room. Then there's a connection like this. And then this could be left alone. So you can sort of clean this up quite a bit. Okay. So let's go with rooms of about 10 to 15. Clean this up. Yeah, you'll get weird dungeons like this, so I'll have to find out why that is with this setup versus, say, the previous. That's fine. And does it ever say too small? Let me look and see. No, I don't think it ever does. Let's do test and grep. Yeah, so it never does too small. Let's run that a bunch of times. Okay, let's get rid of this condition. Right, so this is our room adding condition. And we'll just do return there. And then we can start getting rid of the print statements just to get a better view on this. And also this is for if it's 5. Also these don't match. That might be why we have sort of a lopsided setup. Okay, let's do this. Let's get rid of these. Okay. I don't want to do that, but okay. Yeah, that's better. I think my left or versus right traversal was like lopsided. Let's run a few times. Yeah, I think that's pretty reasonable. Yeah, it does tend to put them around the outside edge though, but not all the time. Okay, yeah, we just gotta, you know, kind of tweak it. Yeah, I think it's just random. Sometimes we'll get rooms around the edge, sometimes they're in the middle. Just totally depends. Yeah, so like that's a good map. Okay. And now, once we turn it into a list, this is our entire drawing in the rooms setup. Okay, so now we need to probably start moving the randomness out of here. I wonder if I should just make that a global. Let me see what else we got. That's fine, that's fine. Also, all these numbers can be kind of parameters. I wonder if... Let's make these match. Instead of 4, let's make that 5. Yeah, I think you get a better output when you sort of make those match. Yeah, okay, that's what's going on. Okay, cool. Further cleanup. Let me see what we can do. We could possibly pull this code out. What's the difference on that? Yeah, I think what we can do is we can say copy those, and then in here we only have to change, like for horizontal, we just say left dot height equals right? Because it copies, copy. Yep, okay, get rid of this. And then right, you only need to set that. And width stays the same. Yeah, so all you're doing is just basically making a copy of those. and altering the 2 parameters you need. Yeah, you don't have to change that. Right, and then this becomes yeah, I think that's better. And then we have our whether to traverse left or right. We have this. Okay, let's confirm that produces the same results. And then we can start to look at the door and path generation. Yeah, because you just have to make a copy of the current one and then modify it based on these. Because it's always going to be basically some copy because you're inside there and you're just basically cutting it. Yeah, cool. Yeah, and there's all kinds of tweaks you can make too. Alright, so now the next thing is, now that the rooms are in a list, it's a lot easier to process them. We can actually zip through them, give them doors, zip through them, and or do random pairs. Just come up with like a random list and then go this one to this one, this one to this one, this one to this one, and then use the extra algorithm to do like a path like that, and then this guy might go over here, and then that guy might go over there, and this one might go over there, and so on and so forth. Until you have all the doors connected. All right, cool. All right. So let me commit this code. How are we done on an ad? We got an ad in about 7 minutes, and I think what I'll do is on that ad, we'll just like do a little break. Yeah, in about 7 minutes. I'll go make some more coffee. All right, so now this randomness generation, this thing's got to go somewhere. Wonder if it should be a global. Yeah, let's make it a global, or at least in this unit. Okay, so then in theory, we can get rid of this. And get rid of this. Yeah, because that's going to be a global, so then make split. Yep, okay. Okay, we don't need that. Don't need that. Don't need that. Okay, let's look for G generator. Okay, we get a random dimension there. Make split should be the only place that's being used. Okay, perfect. Then I can figure like a better place to put it. I think maybe I need like a whole randomness thing. Oh yeah, we gotta change these. Okay, so now we can do a step before the drawing of the map, where we go through all the rooms, we give them doors. And then we can use the Dijkstra algorithm to connect them all, I think. I'll do that thing I did where I inverted it, and we'll see, like, do we have some data we can just, like, do it one time and just kind of randomly walk? Yeah, cool. So now, yeah, let me invert this. Let's invert it. So everything that's wall will become room, and everything that's room will become wall. Then we'll run the Dijkstra algorithm that would just like this on this whole thing. And I'll randomly give every room a door, and we'll see what Dijkstra puts out. If it puts something that we can walk, right, that I can start at a door and I can walk and get to all the other doors, then we do that. But I may not be smart enough for that. I may need some assistance. Okay, so to do that, let me commit this, that way okay, so if I have that, yeah, let's invert. Yeah, so all these things can be settings. We can set like how deep we go when we make it. And it's really interesting how much it changes. Like if I set the depth to 10. Oh. It tends to make kind of like more rooms, and they're smaller. So I think if I'm able to like tweak more settings, you can get like big caverns, you can get smaller stuff. Okay, so we'll leave it at 10 for now. All right, so now make room. So what we want to do is in the constructor, yeah, here. We want this. We want the walls to start off with 0. Input map is fine there. Right? So that makes everything open space, right? Like if I run this now, it'll have no rooms, it'll just be like one giant room. Alright, so it's one giant room. Alright, now we go to draw room, or draw map. We can do make room actually. Let's get rid of that. Yeah, right here, we set this to 1. That inverts it. So this will draw walls basically, but the walls will be where the rooms are. Alright, and so then, so you see, this is a room, but now it's considered wall. You run the Dijkstra algorithm, it considers this all space. So the idea is, I just go and I go through each room, and I kind of give it a door position, like that. And you set those in the same way that I set this to 0 in the input map, set doors to 0, and then the Dijkstra algorithm will basically draw numbers for the optimal paths between all the doors. After that, got to figure out how to do that. All right, so we do that. think the easiest place to kind of do that real quick would be draw map. Right, ads are starting, folks. I'll do a break, and I'll come back when the ads are done in like a minute. Just make a quick coffee. So how do y'all like that way of doing the ads? I think it's better than pre-roll for me, but I'm not sure for you folks, right? But you know, you do a little ad break, I just go get a coffee or a hangout, come back, and then ads are back, or ads are gone. And then people don't see the pre-rolls. The pre-rolls are pretty much just death. Or I can stream on Twitter where there's no ads and nobody cares. And then I get 4 viewers. 4 followers who are on Twitter. Okay. So we got our inverted map. Let's play around. We're going to do draw map. Add some doors. And see what we get. I also might use a bit of color. Maybe I'll make these kind of a light gray so you can see them a bit better. Yeah, I'll draw the walls as gray so we have a little easier to work with. And we'll just put a door at like the same spot on all of these. Okay, see what we got. So within draw room, I mean, in theory, I could do it in draw room or make room. It's kind of what I was doing here. Yeah, so here we have to update the input map. Probably shouldn't have deleted that code. Yes. No, I suppose I could actually do it in the draw map area. Yeah, let's go here. Yeah, because I have the coordinates. I just need to do yeah, it's just going to be X and Y. Let me just draw it. So this is going to be the origin. So it's just X minus 1 and Y minus 1. That'll put it like there. Yeah, I think it'll be fine. It might crash because it's going to go negative at some point, but we can see what happens. Yeah, we just kind of... No, actually we can keep it on one axis and just do a minus 1. So let's say... no, actually I could just go in 1. Yeah, let's do X plus 1. So what we'll do is we'll move in by 1. We'll put it right there. There'll be a door right there. And then we can path to it. Okay, perfect. So we're going to do M input map. The input map is determining where things in the game are. And then the Dijkstra algorithm basically does paths to those things. So we just got to effectively do cur.y cur.x plus 1 equals 1. And that should work without crashing. We will see. I need to run a turning star pit. Keep forgetting that. Okay. So let's take a look. Oh, that's right, but it has to be outside the walls because otherwise the Dijkstra algorithm will skip it. So even though we have an input map there, yeah, it's not really working correctly. It has to be in an active space. Okay, cool. So let's do minus 1, and that shouldn't crash. We'll see. That'll move it up 1 square outside and then over. So we'll have like a little door on the top of every room. Yeah, of course it's gonna crash. Every time. Let's say if Alright, so that makes sure that we don't like step outside and we won't have doors in every room. Okay, cool. Did that work? Huh, crazy. What is my damn problem? Oh no, it has to equal 0. That's right. Yeah, the algorithm looks for lower numbers. That's what we want. I gotta say, man, in the C++ course, I'm thinking this is one hell of an algorithms study. Like, it's very good. Interesting. Y is too high or too low? Weird. This is the general idea. So imagine this door is here. So we would just have to get from this room to this room. We just go 0, 1, 2, 3, 4, 5, like that. So I got to think about like how would we do that? It's kind of like walking. You know, you just kind of walk numbers in the right pattern and we'll get a bunch of like kind of nice tunnels all over. They won't be just like straight lines. X and Y would be there. That's weird. Why the hell is it going up by one? Must be thinking this wrong. Bizarre. Oh, let's just get rid of this. We're only going to just add a few doors. We don't need to do much. Let's run that again. That's really strange. Because X and Y should be the corner of that door. So if I subtract 1, it should just go up 1 square. It's going up 2? The hell? Oh, duh. Because I'm moving the rooms in to give them a bit more space. Stupid. And that's also why I went and did -2. Okay. I swear I'm not dumb. And +2. Alright, so that'll put it on there. Alright, we'll have to tweak this too, you know, like I don't think I need to move the rooms in much. Alright, let's see what we got. Wow. If anyone has a really good course on like basic geometry, let me know. I mean, I seriously need to do some like it's a really weird sensation because I can basically visualize what should happen in my head from my painting experience, but then getting coordinates right is just this obnoxious, because I don't have experience with like using programming to do drawing. It's like making it difficult. I can't connect the two together kind of thing, right? That's what we want to see. Okay, let's throw some color in this map so we can sort of start thinking through an algorithm. But you can see the Dijkstra algorithm, because we put a bunch of zeros. Let's say we're going to say a door is going to be here, right? Okay. So the Dijkstra algorithm gives us basically paths between doors. So we just got to think through, like, how would we make... Because remember, this is inverted, so this is all going to be wall. So what we want to do is from this door, we go punch out that door, punch out this door, or that wall, that wall, that wall, that wall. Then this wall, this wall, this wall, right? Keep going up. We could say you keep going to the next highest until you see a lower number, and then start following all the lowest, right? Yeah. They would do something like that. Which is kind of interesting. And then you'd have some of the tunnels would, you know, basically expand the size of the rooms. But I feel like there's definitely an algorithm that just does this, right? I'm thinking like maybe random walk. That's what jumps in my head, but that's probably like too much. Yeah, so like this one, let me see. So let's walk the algorithm in my head. Let's do a different color. And let's use a pen. Okay, so let me see. I pick a door, punch that out. Then I go to the next highest. From there, just pick randomly. So next highest, randomly. Next highest, randomly. Next highest, randomly. Next highest, randomly. Highest, randomly. Randomly. Okay, and at some point I hit those. So then follow until I find a lower. Okay, then next lowest, next lowest, next lowest, and then we got it. So that would give you that. You could also have it when you hit a square that has, like if you're on 4 and you see 4 and 4, pick any side and then dunk, dunk, dunk. Like that. That would do a path. Let's say this one. We're going to go from here. Okay. Up, 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 up. Okay. Yeah, we can just go any direction until it goes down. Yeah, that might be it. You pick a direction and go in that straight line until it goes down. Then when it goes down, you keep following it on the way down. That could be another one. Yeah, so once you have a room, once you have a list of rooms and they'll have their door locations by default in, like, say, one spot, just to keep it simple, then using the Dijkstra algorithm, we should just be able to kind of walk them and make more interesting paths. So we go up and then up, 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 up. Okay, now we can go down, 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 down. It's almost like you go up until you can't go any higher anymore, and then you start following the path that goes down. Now the other way to do it is to set some of them, I think, to like a negative number and some to 0, like randomly, and I think that'll give you a different set of paths. Because that a lower number is a lower priority, if I remember right, or a higher priority, one of the two. So you can check that out real quick. Okay, so let's say let's just flip back and forth. We're just gonna go actually, yeah, let's just do this. Flip 0, otherwise -1. Okay, do that. We'll see what happens. I forget if you have to set it to but you would immediately find a lower when you turned at the top. Yeah, see, that's the thing. I think you have to pick 2 pairs and then draw the path, and then pick 2 rooms, draw the path. But I'm kind of curious if you can just slap a bunch of zeros on there, and then just walk the numbers. Another one I was considering is run the Dijkstra algorithm, and then just delete all the 9s, 8s, and 7s. Right? Just delete numbers, and then see if you got a path. Delete numbers, see if you got a path. Alright, so let's pick, we pick some are -1, and some are not. So let's see. Oh, I should remove the guy. Hold up. Let me fix this real quick. Yeah, this. Let me comment this out. Alright, so let's see what we get. That's kind of weird. Is this kind of what we want? Oh, that's really strange. Yeah, so I guess this room got a -1. So it's not considered a priority. But this is kind of what you want. So 1, 2, 3, 4, 3, 2, 2, 2, 4. Let me see. And then here. Okay, so that doesn't really do it. Yeah, so you have to use, the input map has to have things set to 0. So this idea of using -1s and 0. We could also try and do it once. Yeah, let's do let's just try, we'll just do like a jank. Basically a for loop. Okay, so if it's less than 2, then we set right, so it's gonna be 0, 1, not less than 2, it stops at tick. So that'll set 2 rooms. One will have a 0, and one will have a -1 for the door. Okay, so we pick just 2 rooms. All right, we find 0 here. And you can ignore that. And these are all like 13, 14, 15. Yeah, so you can pick a door like here. And you go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I think that's going to be the easiest. You just slap a door on one of them, right? Pick a random room that you haven't connected. And then you just walk through. The thing that I'm thinking when it comes to the other way of doing it, where like you set all the doors to 0 and then you walk the numbers, is that's going to kind of guarantee that they're all connected. Yeah, so then you would just have to make sure that you go through the list, you connect pairs of rooms, right? And then you have to connect a few more rooms until you get a fully connected graph, right? But I think there's got to be a way in my brain where we set 0s for all the doors. That gives us numbers that will help us make paths, and we just write an algorithm that just walks numbers until we get like paths. And it also might make the paths to these places look a bit more natural, right? Because they're going to kind of look a little random instead of just like straight lines. Okay, cool. Let's undo this jank crap. Get rid of that, do this. Oh wait, actually, one more little test. Where's that -1? Let's turn that. Let's just set both to 0. Let's see what we get. So just 2 rooms at a time, set to 0. Alright, so we got 2 zeros. Here's a 0, and here's a 0. Now I'm going to draw the path. So I go... And most likely it'll be like away from there. So we want to always go away from the room. So you go up by 1. Yeah, I think it's just a matter of kind of like tweaking an algorithm. Because I could see like you want to do this. And that gives you a path. You could also say you go up. You can say, let's do a new color. Let's say we go We go increasing. And then follow. Yeah, you could end up with like kind of cool paths like this if you did that. And in this case, it sort of doesn't matter. I can set zeros all over, and that gives me sort of locations to path to. Okay, cool, cool. I like this idea. Not sure if I have the algorithmic chops to make it happen, but it is an interesting idea. All right, so one more try. Right, and then what I'm going to do before the next little break, I'm going to use color to sort of like make this a lot easier to read. I'll make the walls a light gray. I'll make the zeros something else, and then we'll have like a little tool to like look at this. But if we take a look again, all right, so I want to connect this room to this room. So I can go from there to there. Okay, we go up by value as much as we can until we up. Like that. That's one option. Let's say go from here to here. We can say we go up less gradually. Yeah, so we always follow the same number. Okay, that's the same. Okay, we go by 1. Okay, that's the same. That's the same. That's the same. Okay, now we're on 2s. That's the same. That'd be interesting, but I think you just end up drawing these like circles like that. So that's not going to work. Let's say we can go from here to here. Go up. Next highest, next highest, next highest. Okay, so when we're here, we can only go to the same number or a lower number. So now we go down, 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 down. I think that might be it. I'll follow a path that goes in increasing numbers. And then when you can't go anymore, then follow a path that goes decreasing numbers. And that'll get you from one to the next. Okay, let's say we want to go from this one to this one. So path that goes increasing, increasing, increasing. We can't go to anything lower, so then we start going down. Like that. That might work. It's also possible that you don't try to aim for any particular like door. You don't just say, I'm going to go from here to here. You just pick a door and then follow the numbers. So you go like this. Keep following it and go down. And we just end up there. Okay, lots of ideas. This one, okay, we're just going to go up, 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 up. Go increasing, increasing. Now we're going to go decreasing, 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 decreasing. Yeah, that's kind of cool. I definitely think there's something there. I think this is going to make like really interesting paths. It's going to make, and I'm pretty sure there's some algorithm that just like do this in 2 seconds with some linear algebra or something. But I kind of like figuring it out. All right, let me see. All right, we got to add in about a minute. Let me take another break. I need a bit of water, and I will be back in like 2 or 3 minutes. right, we're back. So I think the ad frequency is way too high. I wonder why they default to like every 25 minutes. So I'll tweak that. For the next session, I'll have it do like maybe once every hour. If I'm doing a 3-hour stream, that's about right. Yeah, so if you don't want pre-rolls, I can have it do one at 15, then an hour and 15, and then 2 hours and 15. I think that does it. Yeah. Yeah, weird. Kind of strange to have to make Twitch do ads well. And I don't even want ad revenue. I just don't want people to see pre-roll. Because then they never come watch. I see pre-roll for like 2 seconds. I move to someone without it. Or I go watch YouTube. Okay. Oh, okay. Interesting. All right. So we have that. Let's improve this drawing a bit as the next thing. And yeah, let's fire up Turning Star Pit. And laugh every time I see that. So stupid. All right. That's on me. Yeah, I'll leave that there. All right. So where's the draw? Draw text. So this is wall. I want to make that light gray. Let me go look at the FTX UI. Right. Yeah, just add a color. Do they have a gray light? Let's try that. Wonder how we select that actually. Oh, nice. Okay, I'll just pick grays for that. Are these constants? Oh, it's in that. So it's just palette. Palette 16, gray, light. Let's try that. And then do I need to include this? I can go actually look at the menus. Okay, we need color. Oh, it should just be in a default. Okay. That's colors. Where's that at? Screen. All right, and then here should be looks like somebody needs a nap. Is it colors or color? Color. Yeah, I think my my state machine is off in that. Okay, so let's see if that gives us a nice gray for the walls. Didn't do shit. Let's take a look at how they're setting the color. Oh, I bet it's just that that's not a color. Yeah, let's set it to color green. Okay, so that works. So just need to find a color that's actually valid for this terminal. Gray dark. There we go. All right, so we got wall colors, and then we can do a color for each for the doors. Okay, cool. This is an enum, so one, two, 3, 4, 5, 6, 9. So 1, 2, 3, 4, 5, 6, 7. Yeah, we could probably do that. Yeah, let's do oh, actually, I wonder. I think it just toss a number in there. It'll give me some kind of colors. Looks like somebody needs a nap. Let's try it. All right, so force it, and I think we might have it. No. Uh-oh. Looks like somebody That's a pretty bad one. Okay. I mean, it's a damn enum, right? Dumb. Yep. Okay, there's no way to just say use this. I'll have to think that out later. Let's say if we'll just mark the doors, and then we can have actually oh, actually, what we should do is I think that'll be nicer. Yeah, that'll be a bit easier to read, I think. And then up here, do this as yellow. Yeah, so I'll make the rooms yellow so we can see them. We'll make the doors red.
Looks like somebody needs a nap.
And then everything else can be dark gray. If I could spell it.
Looks like somebody needs a nap.
Gray, dark. All right. All right, that's a bit better. And then I'll have to refresh my damn memory on how you convert an enum to into an integer because C++ made it too hard. Okay, now we got something we can work with. So what we're looking to do is basically be able to walk from door to door, zeros to doors, right? From door to door, making tunnels. And for now, we're just kind of putting the door in one spot, but we can always mess around with it. Yeah, so simplest case is next highest, next highest, next highest, and then lowest. So if you're here and you can't go any higher, you go to the same. Can you go lower? You can. Can you go lower? You can. Can you go lower? You can. Yeah. Okay, how about this? Let me see. So if we have, you're here. Okay, you're going to go up by one, up, go highest, highest. Okay, so then you're here. If you can go lower, go lower, 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 lower. Okay, let's do a naive one. Let's just do like a really simple, pick a random room, just the first two rooms. We're gonna run the Dijkstra algorithm on it and see what we get. Okay, draw map. I think that's where we have to do it. Might need to prototype it in the main function. Let's change draw map to place rooms. Awesome. Okay, so that'll place all the rooms. Then we can generate paths. Yeah, make paths. Let's put this back up here because that'll give us like a door to work with. Okay, and then we do make paths. That does that. Okay, let's run that. And then once we make paths.
Looks like somebody needs a nap.
Kind of botched that build. Alright, so we make the paths. Then pick the first two rooms. Let's keep the indexes straight. Yeah, let's just do a small case. We're just going to try to make a path from room 1 to room 2. But let me look at main. Let's comment this out real quick. Actually, no. I'll get rid of it. Hey, why am I doing that twice? Oh, okay. That makes sense. I should be able to get rid of that. Oh, my game crashed. Okay, cool. Okay. So we know the door. We'll definitely have to actually set a variable for where the door is. Like what part of the room. But we'll just kind of fake it for now. No, I think we could probably do it. Hold up. Let's just go. And we'll just come here and we'll do. Just hack that up in there. Okay, cool. That'll get us something going there. Okay, we got doors at the top. Really boring, just straightforward. We'll move this out in a second. Okay, so now we have 2 rooms, 2 doors. We know where the doors are. All right, so we want to yeah, I gotta think how you do this. Actually, what time is it? Okay, yeah, we got some time. I should already have M paths. Okay, so M paths room 0 dot door Y and room 0 dot door X. Let's do that much, and then the ones around it. Let's just print that out. All right, let's see how that works. Interesting. Huh, why is it 5? So let me change main real quick to just print the map and then exit. Yeah, let's get rid of that while loop. Okay, perfect. Six, interesting. I wonder if these are backwards again? Nah, that shouldn't be right. Yeah, the door should be 0, so for some reason it's not getting set to 0 in the paths, even after calling make paths. Weird. That's irritating. So they are getting set, but my coordinates are just off. Where the door is at should be 0. Okay, cool. Oh, these must not be getting set. Door X and door Y. Okay, that's what's going on. Okay, so that's what's going on. That's not what I'm telling it to do, which is kind of weird. Yeah, that should be at least 1. There should be no door 0, so it's getting set incorrectly. It's a reference. Ah, this is not a reference. There we go. That's a copy. Ooh, that's real tough to teach people. That's gonna be just murder. Copies versus references. Alright, what do we get? Yes, that's what we want to see. Alright, there we go. So we have a door at 6, 7, it's 0, and the next one is 0, so probably this one. Yeah. 6, 7. Okay. We have our starting criteria. Alright, so now that we have that, let me think. What we need to do is, let's just do +1. No, -1. So that'll just go up 1. Oh, sometimes they're like on the edge. Well, I guess I could just go left or right. Because I'm just trying to figure out how to draw these things. I'm trying to go up by 1, you know? Or I can just run it again when it crashes. Screw it. Alright, great. So next is 1. Okay. Cool. So then we just need to go, so we have our start, we have next. So we need to go while next. Should probably do I think I need to write a little thing that like scans around each point to find the next neighbor. Yeah, then that's your next play. I'm also thinking I need to go eat dinner. And most likely that'll crash. Maybe we get lucky. Yeah. One more time. Now, yeah, it's always, those are always going to be on the edge, which is irritating. Let's try that. All right, let's take a look. Okay. Okay, so while next is greater than current, current equals next, and next equals yeah, okay. Well, actually, okay, I'm being dumb. I totally need to eat. Okay. Now we can do a while loop. Yeah, I'm just gonna jank this. So we make current equal to the next, and then we make next equal to that, and then each time we go through, we just turn that into wall. Right, crazy janky, but I'm kind of wrapping my head around the problem. What we really want to do is have it so that we see, we pick a point, we look at all the squares around it and pick. But I'm just kind of like going in one direction and see what I get. And we want to do this. Okay. Okay, so I only ran it one time, but I think that's the idea. Go up, and then when I can't go up any further, go down. But I do think it needs to be more of like pick all the neighbors, find out what the neighbors are, pick the next highest or lowest, Move, 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 and then when it can't go any further, go down, down, down. Yeah, because right now what's happening is... I guess it could be greater than or equal to. Alright, let's see what that did. Yeah, kind of like that. So that's going like 1, 2, 3, 4, 5, 6. Yeah, so it's going this way, right? Interesting. Okay. Yeah, I think there's something there. Either what I need to do. Oh, hey, Pinecone. Thanks, man. Thanks for the subscription. See, what I think I need to do is either I just go, I pick any room and I just walk until I hit 0. And then redo the Dijkstra map, right? Because those are kind of dead. So what I do is I go here, right? I go like, okay, I'm just gonna pick a random direction. I found 0. Okay, that's all wall. You know, technically it's inverted, right? So think this is wall, but really it's not. Run the Dijkstra map again, and then I'll get new paths. So pick a new one. And go walk, 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 walk. Okay, Dijkstra map. Pick another one and go walk, 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 walk. And then it'll randomly connect all of them. But I think it'll only connect pairs, so we'll just have to see. Now the other option is don't redo the Dijkstra map. Just keep grabbing zeros and then walking. Just keep track of what I've already connected. Or directions I've gone. Yeah, I think there's something here where basically you just use the Dijkstra map to figure out where to go, right? And then you're just drawing paths to all the different rooms, and it would be more like a cavern dungeon kind of thing, because it'd be kind of random. So it would like run into this and go like that. It would go up here and over there. And then you could see it doing like this, like I had, and it would go over there. This one could go like this. And so on. I think the other thing to do is kind of similar to what the original algorithm is, where you just pick 2, do the Dijkstra map to them, then you go up, but see, then I have to bring the tree back. I like the idea of like the connections are kind of random, and you just have to figure out how to make sure that they all get connected. There's another thing you can do if let's say you say this is the exit to the next level, right? So that goes down. And the player starts here. So let's say red for the player, okay? Now you can use the Dijkstra map, flip it back so that this is all space. So let's say you make your corridors, right? So this map, the player can't get to here. So what you do is you run the Dijkstra map algorithm. It will produce a path, and then you try to follow. You set this to the target, and you place the character, and then you try to follow the Dijkstra map. And if you can't get to here, then you have to run the algorithm again to make paths until you can finally get to here. So I definitely think this is like probably the best way to do it. Or an interesting way to do it, right? Because you're using these numbers, and all you got to do is walk them and keep walking until you've got like paths all over the place for people to follow. Whether that's interesting or not, or makes a great map, I don't know. And I think after that, what I want to do, I'll get these working. So tonight at 10 p.m., we'll do this again. Maybe I'll watch a few more videos for how to do these, how people do these, right? And then after that, I actually want to get to where like I can place a character and we can walk through a map. Like we'll know what the map looks like, but just sort of like walking around. Actually make the character move. Right? Yeah, cool. All right. All right, everybody. Thanks for showing up. I need to go eat some food. I'm getting hangry. And I will be back at 10. I also think I need to let this idea kind of simmer. Go do something not programming oriented, maybe some writing or something. And then when I come back, I think I'll know what to do more or less. I think a big part of it is I need to write a little function that from one point grab the neighbors, right? And then pick the next highest or next lowest. So I think that's probably what I'll do at 10 p.m. is given a square, get the neighbors, right? And then pick the lowest one. So once I got that, then the walk is just neighbors next, neighbors next, neighbors next. And then when I can't go any higher, then neighbors next until I go lower and I hit 0. All right, cool. I will allow you to enjoy the music while I sign off. And if anyone has requests on the music, we can change it up next time. I kind of like this playlist. I don't know. This playlist is not bad. Doesn't get in the way. Nice in the background. Yeah, pretty good. All right. Thanks for attending my TED Talk. See you at 10 p.m. or tomorrow.